So we're looking at the application of Desmos to topic 20. Topic 20 is solving quadratic equations. Second part, we're going to look at page 113, number 2P, and we're going to look to solve this by the quadratic formula. Of course, there's many ways to solve this, but the problem specifically asks that be solved by the quadratic equation. Now, we have previously calculated this, and we found the solutions to be minus 1 plus the square root of 33 over 2, and minus 1 minus the square root of 33 over 2. And the solution to this comes out to this number, and the solution to this works out to this number here. So let's say we start doing this problem, which is right here, and we type it right into Desmos. You can see that we get the same solutions, same numerical solutions that we get here. Okay, we get 2.237 if I round it off, and minus 3.37. So those are the same solutions that I get putting in this and this and calculating. So that's good. Now, if I simplify this equation, use FOIL on the left side, and bring the number 2 onto the left side from the right side, I get this equation. So this is just a simplification of this, foiling it, and then bringing the 2 over to the left side, and we get this. And when we get that, we get the graph. You can see that by the line here. We've got this line here, and you can see we get the graph coming down here. I'm not showing the whole thing. And also, you can see that we can actually show the intercepts exactly as this is a calculation. But if we click on this spot, this intersection and this one here, we get exactly the same answers, the minus 3.7 answer and the 2.37 answer from the graph. But the problem says to do it by find the solutions to x by the quadratic formula. So the coefficient of x squared here is 1. The coefficient of x is 1, so that means b equals 1. And c is minus 8. And if we use those numbers and put in the formula minus b plus or minus b squared minus 4ac over 2a, we get the 2.37 solution. And if we change the plus to the minus and put it in, we get the minus 3.37 solution. So here is the actual quadratic, using quadratic equation, the solutions. Of course, as I said before, these are approximations. This is the exact answer, and these are approximations to these numbers. But you can see no matter which way we do it by asking Desmos to solve for the equation, or we graph it, or we use the quadratic equation. We always get the same answer. So let's move on here to problem page 113, number 2U, solve by the quadratic formula. And again, we did this before, and we found there were 2 solutions, minus 3 plus the square root of 5 over 2, and minus 3 minus the square root of 5 over 2. These are the exact solutions. These are the calculated numbers. So we should get minus 381 and minus 261 if we round it off. So let's see what happens when we put the equation that we're given into Desmos. Desmos doesn't solve this. It doesn't like it. It puts this little triangle here, and it doesn't like this equation. It can't solve it. So one of the things you always have to do here is to find a way, if possible, that Desmos could solve this. So what I'm going to do, If I take the common denominator as x plus 2, x plus 3 here, and I multiply this term by x plus 2, x plus 3, and this term by x plus 2, x plus 3, and this one by the same thing, x plus 2, x plus 3, I come out with this. So I'm multiplying each term, this one, and this one, by x plus 2 and x plus 3. And when I do that, lo and behold, I get the same solutions. It calculates it out minus 0.38 and minus 2.61. And I think that shows you that if you can't get an equation that works in Desmos, how can you make it work? And here you see I've made it work. Now, it still asks us to do the solution to this by the quadratic formula. So what I'm going to do here is just simplify this. I'm going to take this, do FOIL on it, and get x squared plus 4x plus 3. I'm going to do this, do FOIL on it, and get plus x squared plus 4x plus 4. I'm going to do FOIL on this, and get x squared plus 5x plus 6. And notice when I do that, I go from this to this, and the solution doesn't change, which is telling me that what I've done in going from here to here is correct. If this had not been the same as this, we would know that something was wrong. Now I'm going to collect the x squared terms. X squared plus x squared is 2x squared. I'm going to subtract this one, and I get x squared. I add the 4x and the 4x, I get 8x. Subtract the 5x, I get 3x. And here I've got 3 and 4, I've got 7. Subtract the 6, I've got 1. So now, again, I have exactly the same solution. But the problem says, solve it by the quadratic equation. So here, the coefficient a of x squared is 1. The coefficient of x is b is 3. And c is 1. We do the quadratic, and we get exactly the same solutions that we got over here. Now, what I've done is take the problem and separate the left side of the equation, the problem that would have given. I said y equals that, and the right side, I put y equal 1, and that's on the right side of the equation. And you'll see I've got a little line here which indicates the graph. And here you can see what the graph looks like. Now, I know this looks very complicated. This is the straight line y equals 1. So the rest of it, this part here, this part here, and that part over here is all this part of the equation. Now, this is obviously quite complicated, and we don't have to really know exactly how it was obtained as the subject of a more advanced algebra course. But you can see that the intersection of the line y equal to 1 with this equation occurs at minus 268, which is this solution, and at plus 382, which is the other solution. So you can see minus 382, minus 268, minus 382, minus 262. So we've got the same solution. So 3 or 4 ways that we've shown how to do it. We showed the solution from this equation, we showed the solution from the quadratic, and we showed the solution from Desmos. So let's go on to page 114, and we're doing problem 3F. And here you see we have the product of this plus the product of what's in the square brackets equal to 0. And we did this previously, and we found the solution to be 0. And minus 4 plus root 5 over 3, and minus 4 minus root 5 over 3. So here I put in the basic equation, and I get the graph. And you can see from the graph, I can click on the points, I get minus 475 as the solution, comma 0. In other words, x is equal to this and y is equal to 0. I've got this as another solution, which is right over here. Okay. And I've got the 0, 0. So let's take a look at the origin of this. First of all, these values are obtained from the graphical solution. These are from the graphs. We highlight the points and we get the solutions. If I set x squared equal to 0, I get x equal to 0 because if the product of these two is 0, either the x squared is equal to 0 or this is equal to 0. If I put this equal to 0, I get this solution. Desmos calculates. So by calculation here, the 0 solution, which I corroborates what I got on the graph, the minus 235 solution, here it's calculated, here it appears on the graph, here it's calculated, here it appears on the graph. Everything supports it. Now, we had previously, as I said, done this solution, and we found the answer was minus 4 plus root 5 over 3, which corresponds to the minus 235 solution right here. And the minus 4 minus root 5 over 3 corresponds to the minus 474 solution. So you can see that, let me just go over that again. Previously, we had calculated these. These are the exact values. They actually turn out to have these numerical values, and these agree with the solution obtained by setting this part of the equation equal to 0. And they also are corroborated by the graph, which is obtained from this one. Here you can see this is a graph. If it doesn't show that line there, it's a calculated solution. So whether any which way we do it, we get the same solution. I think it shows also the powerful value of using Desmos to solve your problem or help you check and verify your problem. Now we're on 114, number 3T. Solve for x. Again, we put this into Desmos. Desmos doesn't like it. Won't solve it. It's got this little triangle here to get an error message. So what I did was I just changed this and asked it to draw the graph of this. And when you draw the graph of this, you get this graph here, which looks very complicated. I've sort of cut it off just to show the intercepts, because the intercepts are where y equals 0. Along this line is equal to 0. And we essentially see we've got minus 866 plus 866 minus 223 and 0.897. So let's see where those come from. First of all, if we do the calc, if this is equal to 0, then either this can equal 0 or that can equal 0. And the solution to this comes out to be this, which is the 5 square root of 3. In other words, if x squared equals 75, you can then show that x squared is equal to 25 times 3, and x is equal to the square root of 25 times the square of 3, which comes out to be 5 root 3. So the solution to this, and we had found this previously, was 5 root 3, and this agrees with this solution. Now, obviously, the other solution is minus 5 root 3, so it can be plus or minus 5 root 3. So here's the plus 5 root 3, which is this solution over here on the graph, and the minus 5 root 3 is that solution right here on the graph. If we set the other part of the equation right here equal to 0, I get the 896 and the minus 223. So here's the minus 223, and here's the 896 rounded off to 8.897. So you can see again, we've got 4 solutions here. We set this part of the equation equal to 0, we've got 2 solutions. We set this part of the equation equal to 0, we've got 2 solutions. We've got a total of 4 solutions, which is corroborated from the graph. 1, 2, 3, 4 points. Now you say, oh, I don't really understand this graph. You know, at this point, what we really have to look for is key in on and look for the x-intercepts, and those give us a solution. Now, we also showed that when you use this we used the quadratic on this, and we did a calculated, came out to be -2 minus root 22 over 3, the exact solution. By the way, this is just an insertion point. It shouldn't be there, so don't worry about it. And I also changed this from a minus to a plus, so we get the -223 and the 0.896. That's where the origin of these come from. Just like the plus 866 and the minus 866 are really the exact solution is 5 root 3. So we had previously done this, and now you can see that Desmos calculates this as -223, which is this point, and it calculates this one here with a plus 896, which constitutes that. So again, we're using Desmos to support our answers and look at the graph and look at the problems in a different way. So page 114, number 6C, find a quadratic equation with the given solutions. So we're given the 2 solutions as 1 plus root 5 over 2 and the other solution as 1 minus root 5 over 2. And I put, in order for this to give the plus solution, I put this in. In order for this to give the minus solution, I put this in. So the product of these two will give you 0. Okay, and one of the solutions is 161, and one of the solutions is 0.61, negative 0.618. So I'm going to rearrange this, and what I'm going to do is bring the minus 1/2 out here and combine it with the x. So I've got it over here. And I'm going to bring the minus 1/2 out here and combine it with the x. And then just take the other term, the minus operating on the plus here gives me the minus, and the minus operating on this minus gives me a plus. So what I've done is I've essentially said this is A minus B, A plus B. So it's the difference of squares. So I did this, and then when I moved this from this to this with the rearrangement, notice that this doesn't change. So I must have done it correctly. So I've just done that to simplify it. Now I can write this as a difference of squares, x minus 1/2 squared, the first term squared, minus the last term squared. And then by the square root of 5 over 2 times the square root of 5 over 2, I get minus 5 over 4. And the reason I get a minus is this is a minus and that's a plus. So I multiply the numerator by the numerator, I get 5, the denominator by the denominator, I get 4, and the minus times the plus gives me the minus. And lo and behold, I get this, same as I got before. Now I simplifying this, using FOIL on this. The whole thing is to make this a much simpler, and I think you will agree as we go along now, we've simplified this formula. So this is very complicated, but the identical formula as we move down gets less and less, and here we are down here. So I said this was the difference of squares. So I'm using FOIL here. First times first is x squared. I combine the inner and the outer. I get minus a x, because I've got minus 1/2 x and minus 1/2 x gives me 1 minus 1x. And the last, minus a quarter times minus a quarter gives me plus a quarter. And this is minus 5/4 here. Notice doesn't change. That shows that I'm doing everything right as I go down. If I made an error in going from here to here, these numbers wouldn't stay the same. I combine the plus 1/4 with a minus 5/4, and I get minus 1. Same solution. So there's the much more simple answer. And if you ran this and you said to yourself, okay, I use the quadratic here, I would go back to the original equation. You could use the quadratic and you would come out with this solution, both the minus and the plus. You could try that and make sure that it works. Now, we're on page 114 times 7b. Find k such that 1 minus root 2 is a solution of x squared plus kx minus 1. You got to find k. You know x, one of the values or the value of x that works for this equation and makes it equal to 0 is when x equals minus 1 root 2. So now I substitute 1 minus root 2 for the x, and because this is squared, that's squared. I don't know what k is, but I know what x is, and I replace this x by minus 1 minus root 2, and this is minus 1. Lo and behold, it gives me the value of k. Now, here I plot this equation. Okay. This is an alternate way of doing it. This is a calculated value. It's told me that k is minus 2. So, alternate way, I can plot this, put the same equation in, but make it equal to y. And now, if you like, in a sense, x becomes my, k becomes my x along here. And we want this where y equals 0, and it does equal 0 at minus 2, which is identical to this right over here. So whether I do the problem graphically or I do the problem by calculation, I get the same answer. Now, here, find the greatest value of k such that 2x squared minus 5x plus k equals 0. Note that in this sense, we can consider k to be the y-intercept because you get the value, this is c in ax squared plus bx plus c, and if x is equal to 0, then y is equal to c. So once we know the y-intercept, we can calculate this problem. Now, what I did here was to put in y equals 2x squared minus 5x plus k. And it won't do anything. It'll give me a slider for k. And I changed the slider value to 25 over 8, which is 3.125, which we had previously calculated. Okay? So, when you do that, you can see that this middle graph here, I have 3 graphs now, where I've also added 2 other graphs. This is 2x squared minus 5x plus 25 over 8, because I put it in over here. Now I've changed also, and I put the c value or the k value to 4 and 2 to show you what happens. Now, here is the value for 2. This is this line over here. And you can see there are, you take this graph, that we have 2 values here. When I set k equal to 25 over 8, I only have this value. And when I set it equal to 4, I have no values. So it's okay with 2. It's okay with 3, 1, 2, 5 because y does equal 0 here, but it's not good with 4. So I can move it, it cannot be more than 3.125. The moment that it's more than 3.125, the intercept will be higher, and the minimum, it won't touch the x-axis here. So it won't work. So the maximum value is 3.125. Once it goes above 3.125, it's no longer. It says find the greatest value of k. And here the value is 2. So there are 2 x-intercepts. Okay. Here there's only 1. And once it goes a little higher than that, there will be no x-intercept, like with 4. And so the maximum value is 3.125. Greatest value of k that makes y equal to 0 is 25 over 8, which is calculated to be this. If k is greater than 25, then y does not equal 0. Thus, for y equals 2x squared plus 5x plus 4, k equals 4, and there is no x-intercept. For k equal to 2, there are 2 intercepts. Okay, now we're on page 115, number 12, and we are asked, given certain information in this formula, we know the value of A, we know the value of P, and we're asked to calculate R. So first thing I do is put in A, put in P, the sliders are put in. Those can be changed, or you can just use the fixed value if you want, or do whatever. So I put these values in, and it automatically added these sliders. Now, I isolated 1 plus R squared on this formula, so the unknown is on one side. And if I divide this by P, this side by P, and this side by P, I get 1 plus R squared equals A over P. And you can see it uses the value of A, it uses the value of P, and calculates R to be 0.378405. Now, this is a compound interest, which essentially means that if you leave this number up here, really means that it's been left for 2 years. If you wanted to change it to 3 years or 4 years, you could. But it says, okay, if you have 2 years and you're starting with this and you want to land up with that, what would the rate of interest have to be? And the answer is 37.84. This is in decimal form, but in percentage form, it would be 100 times this. So anyway, I think that's kind of an interesting thing. Now, the negative solution doesn't apply because you can't have a negative rate of interest. You wouldn't go into a bank and, at least I hope you wouldn't go into a bank and they say to you, well, we're going to charge you for keeping the money with us, and we're going to give you less at the end than you would at the beginning. So I don't think that would be very viable. Now, here what I've done is I've graphed the problem, and I've made y equal to 475, p equal to 250, and you can see that when we do that, we have the intersection here. Here's y is 475, and we intersect it with this graph here, and we get the solutions. See, the y is 475.378. That's the rate of interest fraction on decimal. It's actually 37.8. So we get the same solution here that we did by calculation graphically over here. Again, very useful way to use decimals. Find the dimensions of a rectangle. Its perimeter is 100 centimeters and whose area is 220. So here we have 2x plus 2y equals 100. X is the width and y is the length. It doesn't matter what is the length and what is the width, as you'll see. So we got 2x plus 2y equals 100 and xy equals 220. That's the formula for the area. The length times the width gives you the area. 2 times the length plus 2 times the width gives you the perimeter. That's what we're getting. The perimeter is 100 and the area is 220. So what I'm going to do here is take this second equation and solve it in terms of x, replace y, and make y in terms of x. So I look over here, 2y equals 100 minus 2x. Y equals 100 minus 2x over 2. So I replace the y in that equation with 100 minus 2x over 2, and the x is just this x. So I'm using xy, solving for y here, and replacing it. So I've got everything in terms of one unknown. And here it gives me the two values. X is equal to 4.87 width or 45.12 width. Now once I know one, I know the other. It doesn't matter whether you make this the width or that the width. It doesn't matter. Because once you know one, you will automatically calculate the other as the other one. So if I choose this as the width, this would be the length. If I choose this as the length, this would be the width. Okay, it doesn't make any difference. So now, so length is either this or this, and the width is the other one. You sum 2 times this and 2 times that, come out to be 100. You can see that 2 times 45 is about 90. 2 times 4.8 is close to 10, a little less. When you add those two together, you will come out to be 100. Graphically, I just put y equal to the left side of this, and lo and behold, here's the 4.88, and here's the 445.1. Alternately, it might be a lot simpler. This is just an insertion point. I didn't click it off, so don't worry about it. It's not important. 2x plus 2y equals 100, and xy equals 220, and I look for the intersection of these points. And I've got an x and a y value, so you can see it. One could be the length, and one could be the width. And it doesn't matter which. Alternate, this becomes this, and that becomes that. It just rounded off a little differently. Now, here on page 115, you've got the height in feet of a baseball. T seconds after being hit is given by the formula h equals minus 16 t squared plus 76t plus 5. When will the baseball hit the ground? Very, very simple. We can, first of all, put in the formula. So you know this, that's this. You get this graph over here. And you can click on this point, and you can see the ball's thrown from right here. It goes up, reaches its maximum, and then comes down and hits the ground. How do I know it hits the ground? Because that's the y-axis or the h-axis. 0. That's where it hits the ground. This is the ground along here. It's thrown from a height of 5 feet because this is 5. If t is 0, the height is 5. Y gives me the height. So it's thrown from a height of 5 feet, thrown up, and then hits the ground. Notice if I put the equation equal to 0, I then come out with the same calculated value right here that I got over here. Here it's by graph. I know that because of the line. Here it's calculated because I have the box for the numbers right underneath it. Okay? So that completes our discussion of Desmos and its relationship to topic.